Hi guys, so I just want to do a quick video here on what's called accumulators. So when you're programming, there's certain patterns you come across quite a lot, and one of them is called an accumulator. So basically the idea is very simple. You want to count how often something happens, or you want to add certain types of values together, like every even number or every prime number or something like that. So if there's where you want to accumulate certain values or certain letters, like maybe vowels or whatever, that's an accumulator. All right, so here you can see on this line 1 here, we have total equals 0. So 0 on the right-hand side of the equals is our value, and on the left-hand side of the equal is the variable we reference that value with in our program. So as you'll know from class, 0 on the right-hand side of the equals, that goes into memory first. And then when it's in memory, it also remembers the data type. And once that is complete, it links that to the variable name on the left, which in this case is total. So then it moves on to line 2, and on line 2 we have total equals total plus 1. The computer always does what's on the right hand side of the equals first. So it looks at total on the right hand side of the equals, and it goes into memory to find its value. If there is no value, your program will crash, but there is a value here, it's 0. So it says this line is 0 plus 1, which is 1. So then it puts 1 into memory and its data type. And then once it's in memory, it links the value to the variable name on the left-hand side. Now the first variable we had, or the first value, 0 int, that is now got rid of. So that no longer exists because we have updated the reference to the total variable with our new value in memory. So we move on to line 3. It's the same idea. The computer checks this total in memory, and it's now 1, and it wants to add 1 to it, so you get 2 in memory, and the data type is int. And then this gets linked to our variable name because we're using the same variable on the left-hand side all the way down, and this link is now dead. So these values that are no longer referenced, the computer will take care of those. It will free up that memory itself using garbage collection or something similar. So we go on to line 4. Line 4 gets what's on the right-hand side of the equals first, goes into memory, finds total, which is 2, and adds 1. So we now have the value 3, and it's integer. And this, after it goes into memory, is linked to that, and our previous reference no longer exists. So hopefully you can see that as we run through the lines, we're accumulating the value of total. We're adding 1 to it all the time. So it's constantly accumulating. So if we go on to line 5, we get total from memory. We add 1 to it, gives us a value of 4. That comes in the integer data type. And then we update our reference to our variable on the left-hand side, and that no longer exists. And one more time, we come to line 6. Total in memory is 4. We add 1, we get 5. And the data type is int. That value is linked to our value in memory. Our previous value no longer exists. And then on line 7, when we come to print total, it looks in memory, sees the value 5, and we get our output. So that's an accumulator. We're constantly adding to the same variable a new value. So we started at 0, then we added 1, we added another one, and another one, and another one, and another one till we were finished. So we accumulate as we went along. So when you want to accumulate in code, this is not a very nice way of writing code. Can you imagine if we wanted to accumulate 100 numbers, writing 100 lines of code? And I only chose one here out of convenience. There could be loads of conditions on what values we're adding on to our total. So what we want to do is we want to use loops. The first thing you want to do is initialize a variable with a starting value. So if you look back here, on line 1 of our code, we initialized total with a starting value of 0. So that's the first thing we have to do. The second thing we want to do is inside a for loop or a while loop, update this value. So total here is updating line by line, but no one wants to be doing this. So what we want to do is have a for loop to take care of lines 2 to 6 for us. So they're the major steps. And then the final thing is the variable whose value you are updating is called the accumulator or the running total. So here, total, which is the variable we are updating on every line, is called the accumulator or the running total. So here you have, for comparison, the long way of doing the code. And here we have the short way of doing the code, which is what you would do normally. So in both cases, we create our variable and we give it an initial value. And then instead of writing out this, which would be terrible because if we wanted to change the number of lines, we have to go in and modify the code, which could cause all sorts of problems. We put it in a for loop, and all we would need to change is the value in here to change our code. So this for loop runs exactly the same way as the code on the left-hand side. Range 5 will go from 0, 1, 2, 3, 4. Remember, it goes from 0 up to, but not including this number. And if we run this code in Thonny, we will see that we get the same output as we had here. So I'll just show you that quickly. I press F5. All right, so the output here in the shell is 5. And you can see how we are accumulating the values because we are constantly updating the total on the left-hand side. I hope this is making sense. When we want to update a value, we use its name on the left-hand side and on the right-hand side, and we add to it. And that is called an accumulator or a running total. All right. When you are adding numbers, the order you accumulate them in does not matter. So what I mean by that is, if I want to add 1 to the total, I can add 1 plus the total, or I can say the total plus 1. Either way, it will make no difference, because when the computer comes to this variable total, he's going to go into memory, get whatever value he has, and add him on. So it doesn't matter if you add 1 plus 5 or 5 plus 1, you get the same answer. Okay? So when I have a for loop, like I have here, I can say total equals total plus 1, or total equals 1 plus total, and it won't make any difference to my answer. But that's for numbers. For text, it makes a difference. But we'll get on to text later on. So, one final question, is the initial variable always 0? So you can see here, I set the initial variable value to 0. Here, I set it to 0. And is it always 0? And the answer to that is no, it is not always 0. It depends on what you want to accumulate. So, for example, if we look at this code here, I want to calculate the product of some numbers. So I have set the starting value to 1. If I set the starting value to 0, this value will start at 0, and anything multiplied by 0 is 0, so this will be 0. And as I loop around, I'll show you quickly here, actually, in case I'm going too fast through this. If I just move this guy over here a bit. Okay, assume I had set total product to 0. Well, 0 would go into memory as an integer. I have to go for I in range 1 because by default it starts at 0, which would also cause me a problem. Anyways, I will take on the value 1. So 1 will go into memory as an int. And this will be linked to I. And this will be linked to my total product. All right, so what's going to happen is total product here on the left-hand side of or on the right-hand side of the equals. The right-hand side of the equals always gets evaluated first. The computer will run into memory and find total product as a value of 0. So then it will say 0 times I, and it'll run into memory and see I is 1. It'll go 0 times 1, and that will be equal to 0. So the value here after the first calculation is going to be 0. So there's no change in my value here. This value of I, my for loop will go around again. I will take on the value 2. So 2 will go into memory as an integer. It will be referenced to I in my program. This old reference will cease to exist. And then, if I just tidy this up here, the computer will go and it will take the right-hand side first. It will get total product in memory, which is 0. It will multiply that by I, which has updated to 2. But 0 times anything is 0. So this value here on the left-hand side of the equals, that will still be 0. So there'll be no change here in total product. I will go around again in my for loop and it'll become 3. And hopefully you're seeing the picture now. I is constantly incrementing, but because I'm constantly multiplying the value of I by 0, the new value of total product is always 0. And so my total product never changes. So what I'm trying to say to you is, if you're adding values to an accumulator with a plus sign, like we did back here, you set the initial variable to 0. If you want to multiply, so if you're calculating a product or a factorial, then what you need to do is set the initial variable to 1. Because if you set it to 0, you'll never get higher than 0 when you're multiplying. And the second point, which I alluded to a few moments ago, range by default starts at 0. So if I say for I in range, that's going to give me the numbers 0, 1, and so on up to 4. But that doesn't work for me because the total product will be set to 0 by the first value and everything else then will stay at 0. So in the range, I had to specify 1 to 6. So I'll show you that briefly on Tani, and that's the end of my video then. All right, so I'll just run this program with the values it has, and the product of the first 5 numbers is 120. Okay, so then instead of having total product at 1, I'm going to set it to 0, and now my output is 0 for reasons I've just explained. And if I put that back to 1 and change the range here to 5, again my output is 0 for the reasons I've just explained. All right, so hopefully now you see what we mean by an accumulator and how it works. You can put conditions on this. So if I only wanted to add even numbers, I could say if I modulo 2 equals 0. So remember, modulo, that guy there, that percentage sign, he gives you the remainder after division. If the remainder is 0 when you divide by 2, then it's an even number. So that would give me the product, if I change this a bit. That's the product of the even numbers between 1 and 5. So the even numbers between 1 and 5 are 2 and 4, and 2 by 4 is 8. If I wanted the product of the odd numbers, I could change that to 1. That's the product of the odd numbers. And then if I wanted multiples of 3, I would make that 3. If I wanted multiples of 8, I'd make that 8, and so on. So you can put any conditions you like in here, but underlying it all is the very simple idea that we accumulate by setting a variable outside to an initial value and constantly update that inside our loop by having its name on the left-hand side, which takes the updated value, and on the right-hand side, which we manipulate to update. All right, so I hope that made sense, and I hope that clarifies a few things for you.